If at any time you've looked into upgrading your 3D printer's bed or you've looked into flex plate systems, there's a good chance you stumbled across the company WhamBam Systems. On this channel alone, we've covered quite a few of their different flex plate options, their PEX, which is their smooth surface, their powder-coated PEI, and their latest resin flex plate systems, which I have installed on quite a few different 3D printers, and personally, I love them. What you might not be as familiar with is with their product called the Mutant that originally was announced earlier this year, and it is a very different product, which is a tool changing system that can be adapted to most 3D printers. Now, during this initial period when it was announced, Thomas Sandlander did a video where he covered the Mutant. He talked about how to install it, how it works, and quite a few different things surrounding that, as well as some critiques or things that he felt could be improved upon. Well, based off that feedback and based off some additional community feedback from different beta testers, WhamBam decided to, instead of releasing initial Mutant, go back and make some quality of life improvements and changes, which is how the Mutant V2 was born. I've had the Mutant V2 for some time now, and I've got it installed on one of my 3D printers. So in today's video, we are going to talk about the differences between the original announced Mutant and the Mutant V2. We'll go over what the install looks like and how I installed it, which is kind of a unique install based off of my specific needs and applications for it. We'll cover some of the different things that I think that this can be very handy for, and of course I will give you my overall thoughts on the system as a whole. There is definitely a lot to cover, so without further ado, let's get right into today's video. So starting off, let's take a look at how the Mutant system works. And in a nutshell, the Mutant system contains two primary pieces, which are your fixed plate. That is going to be the part that you will mount permanently onto your 3D printer's carriage. And then you've got the various mobile plates, which you can configure with whatever sort of extruder and hot end setup that you want. And you can even do things like add diode lasers, small spindles, paste extruders, pen plotters. It's really up to you and what your specific application is for installing the Mutant device. Both the fixed plate as well as the mobile plates are made of injection molded glass-filled nylon, and they slot into each other using a dovetail system as well as a snap lever that makes sure they make a very secure physical as well as electrical connection. Speaking of the electrical connection, that is done through a set of pogo pins found on top of the fixed plate. The mobile plates will have a set of exposed pads on the bottom of them, and so when you dovetail the mobile plate into the fixed plate and snap that lever in place, it will ensure that that electrical connection is solid and that there is not going to be any movement going on. This is an upgrade from the original Mutant, which used more traditional pins found on something like a Raspberry Pi that's slotted in, and WhamBam states that these new pogo pins are rated for over 10,000 cycles. Other key differences between the original Mutant and the V2 that I've been testing out are the addition of a block of terminals on top of the plates, bringing it to a total of 18 terminals rated at 3 amps each, as well as two beefier terminals rated at 10 amps that are for things like your heater cartridges. They also completely changed the mounting system. On the original V1, there was basically holes that you could mount things to, and on the V2, it now uses a slot system as well as square nuts that you can put into the slots on the back of the mobile plate, which gives you a lot more mounting options. This is one of the things that Tom had mentioned in his video he thought would have been a better choice, and so I am really happy to see that that was implemented because I do think it is a better solution. Another thing that Tom mentioned in his video was that some of the different parts seem to have a bit of warping to them, which was likely from the manufacturing process, and although it didn't have any effect on the functionality of the parts, it just wasn't the nicest. And I am happy to announce that on the V2, the fixed plate, the mobile plate, and the levers, all those different things did not have any warping at all, so it seems like between the original announce of the Mutant and the V2, all of that has been remedied. Now that we've covered some of the more technical aspects of the Mutant, what does the install process look like? For this, I decided to use the Elegoo Neptune 2 because it is completely stock and it has not been getting nearly enough love, and so I figured by installing this I could sort of unlock it and give it some increased functionality. So I went ahead and removed the stock fan shroud or fan housing as well as the stock hot end on the Neptune 2. I placed those off to the sides, and then I undid the belts on the X carriage and I removed the back plate that was the stock one on the Neptune 2. As far as actually mounting the fixed plate to your 3D printer, you have quite a few options. One, of course, you can design your own back plate. There are quite a few different models that have already been designed that you can print out to be used, and WhamBam does sell two aluminum backplates, one to be used on 2020 extrusion similar to the Creality printers, or in this case the Neptune 2, and one that can be used for linear rails. So I opted to use the aluminum backplate that is intended to be used with the 2020 extrusions and V-slot wheels. Installing that was really simple, and I just used all of the stock hardware that came on the Neptune 2's backplate, as well as 2 flathead screws that came with the Mutant kit. And then I went ahead and used the included belt that also came with the Mutant kit because I needed a slightly longer belt, and then I bolted the fixed plate onto that new backplate. Next, I took one of the mobile plates and latched it onto that fixed plate. I took the stock fan housing as well as the hot end, threw it over the front of the plate, and made sure that I knew roughly where on the mobile plate I was planning on mounting it. And then I cut all the wires for the hot end thermistor and those fans. Make sure to give yourself some extra slack so that way you can actually get them into the terminals. You can always cut them shorter after, but of course, adding on additional length to the wires is much more challenging. Now it came time to actually bolting all this stuff to the mobile plate, and luckily for the hot end, I was able to find 2 slots that it lined up perfectly with, and so I took an included spacer, I bolted the hot end through the spacer into 2 square nuts, and it was locked and loaded on the mobile plate. The issue I ran into was the stock fan housing, or the fan shroud cover, didn't have anywhere that lined up specifically with the holes on it, at least not where I needed it to be to make sure that the fan was cooling the heatsink as well as cooling the the printed layer adequately. So I went ahead and hopped over to Fusion 360 and made a super simple adapter where basically the fan shroud will bolt into it, and then that will bolt into the mobile plate. Once I had everything bolted to the mobile plate, I then went ahead and did all of the wiring. I did use 2 ferrule connectors for the hot end because I had ferrule connectors that were small enough and those terminals are slightly larger. But for the rest of the terminals, I was unable to do so, so I did just go ahead and strip the wire down and put those directly into those terminals. And once that was done, I went ahead and it was time to install the wires coming from the printer's mainboard to the actual fixed plate to give juice to the mobile plate. And to do that, it's pretty simple. You're just going to need to remove 4 screws that will then give you access to the matching terminals that are on top of that fixed plate. During this whole wiring process, WhamBam does include stickers with like all of the mobile plates as well as the fixed plate, so that way you can use the little stickers to make sure you're lining things up correctly or make notes of what you wired into where. I decided to sort of just bypass this because it was very easy for me to know what I was plugging into where, and if it does ever get that complicated, I'll probably just throw up some kind of a simple spreadsheet to kind of keep tabs of what letter corresponds to what wire, but they do at least give you that option in case you want to install that and make sure for peace of mind that you're wiring in all of the things to the correct slots. After I had all the wires connected, I was ready to power on the printer and make sure everything was working, so I switched it on, saw that the thermistor was working, the hot end was able to heat up, which then kicked on the hot end fan, and I was able to turn on the layer cooling fan, so everything was working correctly. And I did want to run a test print just to make sure that all the connections were still working securely and that I had nothing loose, so I went ahead and homed the machine, and that is when I saw that with this new back plate, at least on the Neptune 2, I was not actually able to hit the X Endstop. The belt basically just comes out at a little bit more of an angle, and so that was causing a slight issue. And so I ended up ripping off the stock X Endstop housing, reversing that design into Fusion 360, and then just scooting over the Endstop mounting holes ever so slightly. So it almost looks like a 1-to-1 to the stock Endstop housing, but again, the Endstop sticks out a little bit more, which allows it to hit. I did upload both the back plate to mount the stock fan housing as well as this X Endstop adapter to things, so those will be linked in the description in case you do pick up the Mutant and you do install on a Neptune 2, you won't have to design those files, you can just print them out. Once I had the X Endstop installed and working, I homed everything and then did a quick little releveling to make sure that my nozzle was the correct distance away from the bed. I ran a simple test print, saw that everything was working, and I was ready to move on. My specific application for the Mutant is to turn the Neptune 2 into kind of like a testing platform / multi-use. If I get different hot ends or extruders in to test out, this is going to be a really solid machine to create a simple mount onto one of the Mutant mobile plates and then test that out. I also don't have a laser engraver in this space. My CO2 laser's in storage from when we moved, and I do have the need to occasionally engrave some stuff like acrylic or light wood, so I may be installing a diode laser onto this in the future. So now that I had the stock hot end and extruder set up working correctly, I decided to turn my attention to the BQ-H2, which is an all-metal direct drive extruder hot end combo that I've had for some time and I've been wanting to use, and it's going to be perfect for when I want to print flexibles on this machine or some more kind of higher temp advanced materials. Similar to how I had installed the stock hot end and sort of fan housing for the Neptune 2 on the initial mobile plate, I went ahead and rinsed and repeated for the H2, and I was able to find a design someone had already created for the H2 to mount it to the Mutant mobile plate. So I went ahead and printed that out in ABS, and then I found a completely different cooling solution that I also printed out that used a 50-15 blower fan, and I mounted that onto this tool head as well. And that is a huge plus, is that WhamBam did have quite a few different beta testers for the original Mutant, and so there are lots of designs available for many of the popular printers out there and different hot end configurations. So although the sky's the limit as far as what you want to be able to design for yourself, you can take a look if design's not your thing, and there might be enough tool heads out there to where you can find sort of the solution already that you're looking for. It was during my install of the H2 that I realized I had sort of complicated things, at least based off my specific application, which might be quite niche, but as stated, I want this to be a testing platform because of how easy it is to design different tool heads for the slotted back plate and then quickly swap things out. And I wanted the ability to use both direct drive as well as Bowden setups. When I want to print a bit quicker, maybe I want a Bowden setup, or I wanted to have as many options as possible. And since the stock extruder on the Neptune 2 was Bowden, I hadn't ran the stepper motor cables to that fixed plate. Now, I could easily do that, but if I then ran those motors from the stepper motor, extruder motor to the fixed plate, then I would no longer be able to run it as a Bowden setup, and it would be exclusively a direct drive setup. So the solution I came up with was to basically piggyback off of the wires already going into the stock extruder motor. So I went ahead and exposed the wire on all 4 of the stepper motor cables and then installed wires from that into the fixed plate. And my thought on that was, there are many 3D printers out there where there is one Z stepper motor driver and the stepper motors are ran in parallel with each other, so that way they are powered off of that one driver. Now, I probably could do that for the sake of the extruder as well, but my plan is when I'm going to be running it as a direct drive, I will simply go ahead and unplug the one plug going into the extruder stepper motor, and when I want to run it as a Bowden, I will go ahead and plug that in, and I won't have to worry because the wires going to the fixed plate, they won't be connecting to anything on the mobile plate because I will have configured it as a Bowden setup. So I was very happy with that fairly simple solution I came up with, and that is when I ran into a bit of another speed bump. And swapping out different hot ends with different nozzle sizes is no big deal at all. But when you start swapping different extruders, you've got other factors at play, specifically E-steps. And the BQ-H2 has a very different E-step that is required in order for it to work compared to that of the stock Bowden extruder on the Neptune 2. And so there are things I could do, like create specific G-code files on the SD card where when I swap tool heads, I basically need to scroll and flash, or I could hook up the computer to a terminal and update the E-steps every single time, but that all sounded like a giant pain, and I wanted things to be as painless as possible. The answer I ended up coming up with, which is something that 60 or 90 days ago I never would have even considered because I had no idea how it worked, was using Klipper firmware, and that's thanks to my recent Voron 0.1 build. And the reason for using this is that Klipper makes it incredibly easy from the browser on your phone or on any computer to quickly change those settings in the firmware with just, a click of a button. And so my thought process was that if I had all of the different E-step values in my configuration, when I swapped a tool head from either my phone or from the computer right next to it, all I would have to do is uncomment the correct E-step value, comment the incorrect E-step value for that tool head, and hit the save button. So it would take really just a matter of seconds and I would have those correct values. And that is exactly what I did. This was my first time converting a 3D printer from Marlin over to Klipper, and luckily there was already a config file available, which made it a whole lot easier. And my original plan was to use just a Pi Zero with a 24 volt to 5 volt buck converter, which is exactly how I installed it and was feeling pretty happy. And I posted that over on Twitter when Nero, who has a lot more experience with Klipper than I do, reached out and said, hey, you could probably just wire the Pi 0 directly into your board using UART, which ended up being a much better solution, and I am incredibly thankful for that tip. So I was able to do all the things that I wanted to as far as getting the E-step values in there. And in Klipper, I even created a simple text file where I just kept some of the basic different retraction settings for the different tool heads. So that way, as I go, I've got all of the information I need in one place that's super easy to access. So currently I'm running with those two tool heads. I've got the stock tool head, which will be used pretty much exclusively for PLA because it's a lightweight Bowden setup. And my experience with the Neptune 2 is that the stock setup handles PLA like an absolute champ. Then I've got the H2, which so far I've done just some PLA testing as well as some TPU testing, but I will absolutely be using it for some higher temp materials. I'm hoping in a few weeks' time to add a diode laser to the configuration, and then I've got a couple other build plates that I'm going to hold on to until the need arises for me to install some sort of custom configuration. The one tool head I would really like to build is a 2.85 millimeter tool head. I don't have any 3D printers at all that take 2.85 millimeter filament, and I don't need a dedicated machine for that because I don't really get much of that filament in. However, it would be awesome to have the ability to just swap on one of those tool heads quickly because 2.85 millimeter filament does go on sale a lot more than 175 because there's just less machines using it. And if I just get some neat material in that's 2.85, again, it would be really, this is a great solution for being able to print with that material when you need it. I will admit that my specific niche use case for the Mutant is a bit insane, and that is also the reason why Klipper made a lot more sense for me. For a lot of other people, depending on how you're planning on using this setup, you might not need to do nearly any of, or the majority of the complex things that I added as far as Bowden to direct drive options, as well as installing a completely different firmware. During my time using the Mutant, I really did some brainstorming on some other applications that I felt that this could be really handy for. Again, aside from my kind of unique situation where I'm testing out a lot of different hardware. And the first was, if you're somebody that wants to create sort of a 3-in-1 or multi-purpose machine. For example, I was just looking during the time of using the Mutant, and the Snapmaker 2.0 is a 3-in-1, I believe, that uses a small spindle, a diode laser, and a 3D printer head. And the price starts at, it looked like $1,000 to $1,500. Well, if you get something like a, or if you've already got something like a Ender 3 or a Neptune 2 or something like that, and you can easily create similar tool heads, and it is going to be way less expensive than going with something like the Snapmaker. And you can also get bigger build volume because you can throw it on something like a CR10 S5 or S4 with a 400 by 400 millimeter build volume. So definitely having different tool heads if you don't need a dedicated laser, or you don't need a dedicated CNC machine but want to be able to do some occasional lightweight work with those tools, that is a great use case for the Mutant. Another use case that I thought of that I think it can be super handy for is someone that's running a print farm, either selling their prints that they designed or prints from others that they've gotten permission for, or offering a print service. I mentioned in my video on things I learned from running a print farm that having the same kind of hardware across your machines makes a lot of sense because you don't have to keep all sorts of different spare parts. You can keep just one kind of nozzle, one kind of hotend, one kind of extruder. And so having this setup, if you've got the tool heads on something like the Mutant and you've got a situation where you've got a deadline to meet, or you've got something going on where you need to get product out the door and you run into a clog, or the inevitable flood that happens one night when you come in, well, instead of having to deal with taking apart and heating up the hot end and trying to pull everything out and salvage it, you can just rip your hot end off, put it onto the shelf, have maybe 4 or 5 spares, swipe it back on, get it up and printing, and take care of that later on. And so in that situation where time is quite literally money lost, it does also make a ton of sense. So we need to talk about the price point of the Mutant, and currently there are 2 main kind of kit configurations. There's the 1-in-1, which is 1 fixed plate and 1 mobile plate for $85, and then there is the quad kit, which is 1 of the fixed plates and 3 of the mobile plates for $150, which I was hoping is going to be a little bit less expensive. And I won't pretend to know what goes into things like R&D or small scale manufacturing, but I again, was hoping for it to be a bit less, just so that way it can be something that maybe more people are inclined to adapt to their sort of 3D printing configuration. That being said, I still think it makes a lot of sense for someone that's doing some sort of experimentation, whether it's for personal or whether it's some sort of educational institution. It still is going to be a lot cheaper to create your own kind of Snapmaker off of your current 3D printer than buying a 3-in-1 type machine like that. And even for the thing I mentioned regarding the print farm or print services, yes, it might not make sense to have it on a bunch of Ender 3s because, you know, at a quad kit of $150 and an Ender 3 at, you know, $160 on sale, you could just have a complete spare 3D printer. But if you do have more expensive 3D printers, things like, you know, Prusa MK machines that are $800 to $1,000, it begins to make a lot more sense, or even machines that are going to be pricier than that. I certainly don't think that the Mutant is going to be something that every single person that 3D prints needs, but it is something that is very handy, and if you are somebody that has a specific application and you've watched this video, I'd say by watching this you'll know if all of the light bulbs are going off for all these different ideas that you have and how you can use something like this, again, whether it's for personal use or whether it's in more of a production environment. Overall, I've been very happy using the Mutant, and I think that as I build out more mobile plates with different tool heads and different just types of setups, I will get a lot more use out of it as I'm able to incorporate it into various projects. The only two things that I did want to mention as sort of, I guess, feedback or just to let you guys know is that on the mobile plate, when you are going to be installing the various wires to it, the terminals are facing backwards. And so you basically have to take the wires, loop them over the top or over the sides of the terminal, and then install them. And although it's not a huge deal, it was a little bit frustrating when I bolted things to the mobile plate and then took the wires, tried feeding them over, and it's just an awkward angle trying to get them in. I don't know if there's a specific reason why they are facing backwards instead of forwards, because I would feel that having them facing forward would make it a lot easier to just directly install those, but that was one thing that was a little bit of annoyance that I wanted to mention. And then also, depending on how thick the tool heads that you're building are and what printer you are installing them on, you might be losing a little bit of your y-axis. Measuring just the fixed plate and the mobile plate, it was roughly 12 millimeters, and so if you add additional plates on top of that, you could then be losing, you know, a little bit more of your y-axis. That being said, I can't tell you the last time I actually used a end-to-end entire build volume, but maybe that's just me, and I definitely think that's at least worth mentioning because it should be something to consider based off whatever your unique application is. If you are interested in the Mutant, I will go ahead and place links down below in the description to where you can find out more or pick up one for yourself. Let me know in the comments down below what your thoughts are on the Mutant and just kind of these swappable tool changing systems in general. And if you've got a cool or unique idea for a different tool head, let me know because I am always interested in different ideas. I know in my video that I made a couple weeks ago, I asked about different ideas for the copper fill material that I had, and I got some really awesome responses. So if you've got a cool application for one of these tool heads, let me know in the comments down below. On that note, don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. And if you do want to support the channel furthermore, I will place links down below in the description over to our Patreon where there are some really awesome rewards. Huge thank you to all of my existing Patreon supporters. I appreciate each and every one of you allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot, and I look forward to seeing you guys in my next video. Peace, guys.